In section 4.3, we're going to deal with mixed and entire radicals. If we take a look at the list of radicals now at the bottom of the page, this is called an entire radical. Okay, all of these, if you notice, there are no coefficients in front of the radical sign. There's just an index and a radicand. These guys here are called mixed radicals because there's a coefficient in front of the radical. Just as with fractions, equivalent expressions for any number have the same value. So for example, the square root of 149 is equal to 16 times 9, which is really root 16 times root 9, which is 4 times 3, which is 12. So we do have the first property of radicals, and that's called the multiplication property of radicals. If we have two numbers being multiplied under a radical, we can take the radicand, or the first number, the radical of the first number times the radical of the second number. Okay, and again, obviously the index would be the same for both radicals. Say we wanted to simplify the following radicals. Okay, so we want to write root 24 and simplify it. So what you need to do, you need to look for factors of 24 that are perfect squares, because we're looking at a square root here. So if we look at 24, factors of 24 are 4 times 6, and the square root of 4 is 2, so I can bring a 2 out, and I'll be left with 2 square root 6. For the cube root of 24, now we want to look for factors of 24 that are perfect cubes. So if we look at our perfect cube list, we're going to have 8 times 3 is equal to 24. And now the cube root of 8 is 2, so it would come out front, and you're left with the cube root of 3. Now, lots of people forget to bring this index down. If you write square root 3, that would be incorrect because it's the cube root of 3. All right, we want to simplify these ones. So again, if I look at the square root of 80, okay, the square root of 80, if I look at my perfect squares, would be 16 times 5, and the square root of 16 is 4, so that answer would be 4 root 5. Now, some of you may be going, oh, what if I started with, said that 80 was equal to 4 times, or 8 times 10, okay? Well, if you started by breaking it down to 8 times 10, okay, well, you could say then that 8 was equal to 4 times 2, and you could say that 10 is equal to 2 times 5. So the square root of 4 would be 2. And then 2 times 2 is another 4. And the square root of another 4 is 2 root 5, which would also give you 4 root 5. So it's often easier if you find the largest perfect square that we're dealing with. But in this particular case, if you decide to do 8 and 10, it would just take you a little bit more work. All right, let's take a look at the cube root of 144, okay? And if I wanted to look at the cube root of 144, I have to look for factors of 144 that are perfect cubes. So the cube root of 144 is really equal to 8 times 18. And the cube root of 8 is 2, so we would be left with 2 cube root 18. All right, if we look at question C, we're looking for the fourth root of 162. Well, the factors of 162 that are perfect fourths would be 81 times 2, and the fourth root of 81 would be equal to 3, so the final answer would be 3 fourth root of 2. All right, I want you to take a second to try these ones on your own. Okay, I'm hoping you had time to try those. So again, we want to look at the square root of 63, okay, and the square root of 63 would be equal to 9 times 7, and the square root of 9 is 3, so we would be left with 3 root 7. The cube root of 108, the cube root of 108 would be equal to 27 times 4 is equal to 108, and then it would be The cube root of 27 is 3, so it would be 3 cubed root 4 would be my final answer. The fourth root of 128, okay, so we look at 128. I can divide 128 by 16, so 128 is really 16 times 8. And now if I look at my value of 16, the fourth root of 16 is 2, and I am left with the fourth root of 3. All right. If we take a look at the square root of 200 in this example, so some people found broke it down maybe into 4 times 50. Well, the square root of 4 is 2, but then 50 can be simplified further, okay? So you notice all three of these people appear to get different answers, but we can now continue to break down root 50 because root 50 is really 25 times 2, and the square root of 25 is 5, so 5 comes out. 5 times 2 is 10, and you'd have 10 root 2. Similar here, we have root 8, and root 8 is really 4 times 2. The square root of 4 is 2, so it would come out, and we would get 10 root 2. So again, you notice if you, in simplest form, the radical contains no perfect squares in the radicand. And if it was cube roots, they'd have no perfect cubes as factors of the radicand. All right, let's write these in simplest form again. So we're looking for the cube root of 40. The cube root of 40, we want to look for factors of 40 that are perfect cubes, and that would be 8 times 5, okay? And the cube root of 8 is equal to 2, so I'm left with 2 cube root 5. Now, the square root of 26, okay? Well, the only factors of 26 are 1 and 26 and 2 and 13, and none of those are perfect squares, so that is already in simplest form. The fourth root of 32, we want to look for factors of 32 that are perfect fourths, and that would be 16 times 2, and the fourth root of 16 is equal to 2, so I'm left with 2 fourth root of 2. Okay, now we want to learn how to go in reverse. So we want to go, how can I write 10 root 2, which is a mixed radical, as an entire radical? Okay, so let's start with 4. Now, if I have a 4 out front, that really means that I must have had a 16 as a factor inside, because the square root of 16 is 4. So if we're going to write 4 root 3 as an entire radical, here's all we do. I leave the 3, and I bring in a 4, and I raise it to the power of whatever the index is. The index here is 2. So therefore, this is going to be 3 times 16, which is going to be root 48. So root 48 is the entire radical of 4 root 3. Now, for 3 cube root 2's, again, same principle. I have my cube root 2, and then if I bring the 3 in, I must raise it to the power of my index, which is 3. So this is going to be the cube root of 2 times 3 cubed is 27, which is going to be the cube root of 54. And for the last one, I have 2 fifth roots of 2, so I'm going to have my fifth root 2. And to bring this 2 in, I would have to raise it to the 5th power. So this is going to be the 5th root of 2 times 32, which is going to be the 5th root of 64. Again, I encourage you to pause the video and give these a try. Okay, hopefully you had a chance to look at these. So we're going to start with the square root, or 7 root 3. So I have root 3 times. If I bring the 7 in, the index is 2, so I have to square that. So this is going to be 3 times 49, and that's going to be 147. So root 147 is 7 root 3. For 2, the cube root of 4. Again, I have the cube root of 4, and if I bring in a 2, it's going to be 2 cubed. So this is going to be 2 cubed is 8 times 4 is 32. So this is going to be cube root 32 as an entire radical. And finally, for the last one, I have 5th root of 3 times 2 to the 5th. So this is going to be the 5th root of 3 times 32, which It's going to be the fifth root of 96. Okay, there's your assignment for section 4.3. Okay, if you have any questions, go back and review the video and check your answers on the website.